I got to talk to Joe Reis today, and I had a great time. Joe is the host of the Monday Morning Data Engineering podcast, author of Data Engineering Fundamentals. He's got a lot to say, not just about data engineering, but real-time data, real-time analytics. Where are these things coming from? Where are they going to? In fact, we went a little overtime, so we're going to make this into part one and part two. Listen in today to part one of me and Joe. Hello, and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined today by my friend Joe Reis. Joe is the co-author of Fundamentals of Data Engineering, and boy, a lot of other things. I'm not even going to try to list them. I'm just going to say, Joe, welcome to the show.
Hey, thanks. Good to see you again.
Good to see you again. Always good to talk.
Yeah, always good to talk.
But you have a podcast. I think you're a fairly well-known personage in the data engineering space. For anyone who happens not to know you, you're co-author of the book on data engineering.
Yeah.
What else? What would you say you do here? Yeah,
well, I'm a Pisces.
Nice.
It's really what we need to know.
My birthday's in June, whatever that makes me. I don't know. I'm an Enneagram 3. I'll say that.
What else? Yeah, I've been in the data space for a really long time. I still do data engineering stuff, still do data architecture as a practitioner. So that's pretty cool. Yeah, nowadays I spend a lot of my time working on a new book right now on data modeling and working on a new course right now with deep learning AI on data engineering. So right now I'm basically a full-time content creator. I still run a consultancy. I have like 5 different jobs. So that's pretty awesome.
Yeah. That's
apart from that, I think kind of tongue-in-cheek known as being a recovering data scientist. My background's actually not in data engineering per se. It was more in analytics, machine learning, that kind of stuff. So, but yeah, that's a bit about me. Yeah, I do a bunch of stuff I don't even know.
Yeah. It's hard to quantify. Instagram influencer? No.
Maybe someday.
Yeah, right. When you retire. So the interesting thing to talk about here on this podcast would be the intersection of things real time and data engineering. And I'll start by saying, I think historically, if I wouldn't even mind if you told us what data engineering is, in the words of Joe Reis. I think that'd be interesting. You know what? I'm going to stop setting up my question. I just like that question so much.
Okay.
What is data engineering?
I think the TLDR, too long didn't read version, the short version is a data engineer sort of sits at the bridge between source systems of data. Mm-hmm. They're typically transactional or operational systems, mm-hmm. and providing that information for downstream use cases, maybe for machine learning, maybe for analytics, maybe for, quote, data use cases. So the data engineer is it's kind of responsible for setting up probably the foundation for helping quote, data use cases succeed, right? Mm-hmm. I think all too often there's this notion that data scientists, for example, they spend 80-90% of their time getting data, cleaning data, processing data, all that fun stuff. And really that should be the job of the data engineers to do that thing. So the data scientists can spend 80-90% of their time doing the job they're actually trained to do. So that's how I kind of look at data engineering.
Yeah,
I give a much more exhaustive definition in my book, but
which is going to be linked in the show notes, right? So
yeah, exactly.
read the book if you really want to know what Joe thinks. But
read the book.
That works, yeah, and a lot of cleaning, right?
A lot of cleaning.
A lot of cleaning. I was at the Computer History Museum a couple months ago now. It's a museum they have in Mountain View. I've talked about it on the podcast before. I can't stop talking about it because it just makes me cry every time I go there. It's so beautiful. And on Saturdays, a couple times a day on Saturday, they have a working demo of an IBM 1401. They have a couple restored IBM 1401s. And one of the people who does the demo was a programmer on a 1401 in 1964. Whoa. It was his first job. Yeah. So amazing opportunity that we have to.
I got to Google that real quick while you're talking.
Yeah, you do. Computer History Museum.
IBM 1401.
Oh, it was a early mainframe, I think first version, 1959, something like that.
This looks like a piece of mid-century modern furniture.
There you go. Ooh. Replica.
I want one in my house just to have
furniture.
It. Yeah.
Okay. I'm making a note of that. That's a business.
Yeah.
Okay.
Yeah.
So the he was talking about historically the way data was brought into those systems, and there were these big electromechanical punch card readers because the data would be encoded on punch cards and read in.
Yeah.
And that process was difficult because the cards would jam, and sorting was a thing. And I'm like, you mean ingest has always sucked? So yeah, there's a lot of cleaning in data engineering.
It's a lot of cleaning.
A lot of cleaning. And then data science. I know that's a super loose term, but you mentioned it's, data engineering provides a platform or maybe a pipeline to get stuff to the data scientist, to analytics. What's the difference between those two things?
Between data science and analytics?
Yeah, you listed them separately, and I don't know if you
mean. So I think that's an interesting one. Let me actually bring up Drew Conway, data science vendor. So data science, when I got into it, this is way back in probably when the 1410 came out. I'm kidding. But it was this hacking skills, math and stat skills, and the substantive kind of domain expertise. Like this is, I think, one of the original, at least, depictions of data science, right? And I think when DJ Patil came up with it back at LinkedIn, I think it was 2009. I think it was a term data science was at least bandied about there. I remember reading an interview with DJ actually when he talked to, I think it was Forbes or something in 2016, but he said that they intentionally never defined it. It was meant more to be a sort of like a way of life or something like that, or a way of working, not really trying to pigeonhole, I guess, in any particular skill set or something. So I think analytics had obviously been around a bit before, analyzing data. That's just trying to find. Analytics is more historically been kind of backwards looking as well, right? So that's looking at data, trying to derive some sort of patterns or insights based on historical data that can be used. For some sort of actions. Obviously, there's other types of analytics, predictive analytics,
right.
And other types of operational analytics. That's something where real time comes into play. And so it's an interesting one. But I feel like over the since the early 2010s, data science has sort of morphed into an all encompassing term that might actually include analytics as well. And so maybe I should have split the difference and said machine learning and analytics to sort of, I think, better define the two things. Yeah, because data science, that's why I call myself a recovering data scientist, because I wasn't sure what it was. I'd often be hired to do data science jobs, and I literally have no idea what I was supposed to be doing. That's why I got into data engineering, actually, because I realized that a lot of the it was an interesting time back in the 2010s, right? Because data was becoming this hot thing. Data is the new oil, and every company's hiring these sexy people called the data scientists who have the sexiest job of the 21st century, according to Harvard Business Review, I think it was.
Oh, okay. And, well, that's good to know.
Yeah, that's what they called it. And so every company was on a spree to hire data scientists, and oftentimes I think it was. There's maybe a lot of FOMO, like if we're not doing data science, and we're obviously going to miss out on this train of data scientists. Our competitors will obviously eat us alive because of data science, and so we got to get these data scientists. And so me and other people who were maybe good at math got hired as data scientists, and I think most people realize, oh, geez, what am I supposed to do now? So maybe they did analytics, maybe they did machine learning, but in a lot of cases, I think the missing thing was the foundational things like, proper data infrastructure, pipelines, ingestion, storage, the ability to query data efficiently, and all the stuff that I think now is, getting a lot more attention, just like data engineering is. But for a long time, that's what data science was. It was sort of this hodgepodge term for people who were, probably trying to figure out their jobs with data, to be perfectly frank. And so, yeah, it's an interesting one. We can go off on a tirade on that, but we'll save that for another day.
Yeah, no, I think that's great for now. And it's kind of, as I see it, whether on the so-called data science end of things, drawing a distinction between building the plumbing and then processing what flows out of the plumbing.
Yeah.
Whether you're training a network or doing regressions or what, you're trying to find the story in the data. That's how I view this whole discipline. Is things have happened, things are happening, and we're trying to understand what the story was or what the story is right now that we can't otherwise see. And it I guess you're describing this process by which the industry learned, hey, wait, it's actually real hard to do that.
Turns out it can be.
Yeah.
Well, I think that people see the success of a lot of the big tech companies, right? Like, all these big tech companies, they're doing this, that, or the other thing. So like we obviously need to be doing that too, even though we're not a big tech company. We sell carpets or something. So,
right.
you know what I mean? So, I mean, this has been the thing. I mean, you're seeing this right now with generative AI and large language models to a big degree, where I think every company wants to jump in on it. And
I haven't heard any buzz about that. What do you mean?
What's that?
No, sorry. Every company needs to be an AI company. Yes.
Yeah, right. So I mean, this is the latest one. I've been around the world, the last year. I don't even know how many times, and it's just interesting seeing the kind of the crescendo of generative AI. It reminds me a lot of the data science days, but it is what it is.
It is, and I mean, like data science, it's hardly fake. It's polarizing and controversial, but we flock like fish as a technology community, and we are doing that. And we tend to overinvest and overhype. But as the hype cycle goes, there's a there, and we'll just it'll take a few years to figure out what that is.
It's fine. It's same as it ever was.
I want to keep unpacking this story. There's the way I tell the story is you had the world of the mainframe. All the data was in one place, essentially, architecturally, and you had some reporting function that would run on that, and it was all there, and architecturally simpler. And then when we started building smaller systems, you had the client server revolution in the 80s and early 90s. Now all of a sudden there's little databases everywhere and applications everywhere. And so we had to build the data warehouse to bring all that back together so you could see everything. So you could see what was going on in the business. So that was it. It seems like that was kind of 1.0 or version 0.1 or something of data engineering was ETL. So number one, I'm going to put that kind of weird claim out there. And I'm wondering, what do you think the story is? Take us from the data warehouse to what you've experienced in the last 15 years as data engineering. It was a new thing. It's a different thing. I'm not trying to say it's all the same, but how's it alike? How's it different?
I mean, it's interesting. I mean, I become super good friends with Bill Inman, who came up with the data warehouse and ETL, this process of it. So it's interesting. I did a podcast a few months ago with him, kind of getting the perspective of, the history of the data industry and sort of where, we all came from. I mean, he was sat front row at that from the 60s and on. So it was interesting getting that whole story, and learned a lot in that conversation. I learn a lot every time I talk to him. I mean, these are a lot of the conversations we just have for hours at his house, but I feel like it's an interesting one. He came up with the data warehouse because it was actually a fluke. Actually, he came up with it while he's writing an article for Computer World one day. Just his idea. Yeah, it was like it wasn't like some grand thing. And I think the name data warehouse came about during a meeting in Canada, maybe in some office. Some lady came up with the name data warehouse. He's like, "Oh, that's a good idea. Let's call it that." Yeah, it's just random stuff, right? And it's like, and I guess he was telling me that data warehouse almost never happened. ETL almost never happened. So it's like, it's interesting seeing these sort of progressions in these, these inflection points that were almost accidental in some ways.
Right.
These are terms we take for granted now, but
there are these multi-billion-dollar investments and to be clear, very good things that were game-changing. Yeah. And that was just somebody said that in a room, and
somebody said that in a room. Yeah. Someone was just like, data warehouse. They're like, "Oh, that's a great. I like that." And so, but it's interesting kind of seeing, but what the way he described it, it was an architecture. It wasn't a way of storing data, for example. It wasn't an implementation. It was an architecture that described like a subject oriented, time variant, non-volatile, way of providing data for management's decision making, right? I mean, that's maybe butchered his definition, but that's essentially what it is. It didn't describe, it's not column store. It's not this or the other thing. I mean, it was literally
like who cares? In other words, about a column store. That's not the data warehouse.
It's implementation detail.
Yeah.
But he described, it was basically a way that you could get away from basically pegging your production databases with analytical queries. That was the intention of it.
Has always been a bad idea. It's not just that things weren't fast enough in the 80s.
Right. It's like it's a bad idea. And so that's where it all started, and kind of where we've gone through to today. I mean, I've been writing a lot about this in my new book. I was just writing a whole history lesson the other day on this, but it was, if you kind of look at the epochs, right? I mean, you have data warehousing, which came about, I think, in the late 80s, early 90s. And then that took off in the 90s through the 2000s. And then you had the internet came about, obviously, and that kind of changed a lot of things. Now you had massive amounts of data. You just never
it stressed that architecture. Yeah.
Stressed the architecture a lot.
The application architectures we were
bingo,
building basically client server systems, and that was
ain't going to work.
Yeah.
It's really difficult. I mean, I talked to the people that built a lot of things like BigQuery and so forth, right? And this is a necessity. It wasn't like this is just some people nerding out. I mean, if you're operating on the scale of Google or Yahoo or Amazon, it's like you had to come up with these different architectures.
Right. And it turns out an order of magnitude, couple orders of magnitude below that, they're still difficult. Yeah.
Oh, it's still difficult, dude. I mean, yeah. It's this common theme where, we solve problems architecturally and technologically to fix I guess to fix a problem, and then that creates a whole new land of opportunities. So you had the NoSQL and big data movement in the 2000s, and streaming, I think became a real thing. I mean, as I talked to practitioners in the 80s and 90s, though, I mean, they were doing real-time eventing back in the day. It's just you didn't have the capability of doing it at scale like you do now, but that was a thing.
Yes. And I will get that note sometimes when I tweet something overly opinionated. About which I try not to do, but I like, I'll say that event-driven architecture is the first real new application architecture paradigm since client server in the 80s. Something that's an opinionated statement. And then I'll get actually it was being done. Yeah, I know. But
actually,
not like
back in
1960,
we were working on this.
Yeah, right. If you look at Douglas Englebart's demo, stop. But it wasn't happening like it's happening now, and so
that's just it. You don't have the scale of data, and I mean, those are the things that have changed. And then I think in the 2010s, data opened up to the world. Back when I got into it, in the late 90s, early 2000s, like data was a job you got because you were like really lame, and which was me. I was originally going to be an actuary.
Really?
Yeah.
Okay.
So, right. I was like, I don't know. I mean, 10 years to get a fellowship seems like a lot of work. I could be a doctor by that point. So as I got into it, but it was weird because I think in the early 2010s, machine learning was coming about, and then data was all of a sudden this cool thing. Everyone was getting into data. I was like, this is the weirdest thing I've ever seen. Like this was something you did because you were more of a social reject, not because you wanted a cool job. And so data became cool. Then I think the real thing I want to pinpoint, I think where everything changed was when AWS Redshift came about. And,
okay.
2012, because I think that was the first time you could get analytical, like a true OLAP technology Redshift for like 25 cents an hour.
Okay.
Starting cost. And that was really cheap because, I mean, at that point, you got to remember before that, for you to get any infrastructure, I mean, that cost you a lot of money, and haggling with aggressive salespeople that would sell you a bunch of servers and on-prem boxes and stuff, and
a bunch of hardware that had
a bunch of hardware,
and some Oracle thing probably,
or some Oracle thing. Good luck trying to get out of that, man.
Right.
I mean, they come and do an audit on your cores and audit on this, that, and the other thing, and it's just, remember these days. I mean, I think that around that time, you saw a lot of open source stuff coming out. I think Kafka was maybe coming out around that time. Snowflake was actually working on that time.
Early 2010s.
Early 2010s,
very
Kafka,
early
I think
Kafka.
Yeah, you saw a bunch of early stuff like Storm, a bunch of technologies coming out, and it was, so a lot of these tech companies obviously were open sourcing stuff that was scratching their itch. But I think when Redshift came about, companies realized, oh gosh, I can do this and not have to pay a lot of money. This is pretty awesome.
Okay.
And the cloud at the same time really, I think, democratized, or at least made it super simple so everybody could start doing quote data, right? And I think that the confluence of like great open source tools, the cloud, Redshift sort of opened the doors, and then you had the modern data stack that sort of took off in the mid 2010s to today. And I think that's changing. In my book, and we can talk about real time in a bit. In my book, in the last chapter, we talk about sort of our predictions for where things are going, and I called it the live data stack. I think this is the next evolution of where things are going, and I still think that that's where it's going. Even though I wrote that a year and a half ago, something like that 2 years ago. And what does that mean? Well, I feel like the modern data stack, and that's really the ability for you to stand up an awesome analytical infrastructure with great ELT or ETL pipelines, great storage and query engines, on a credit card using SaaS-based tools that are interoperable and modular. That same thing is coming to real time now. I think for the longest time, real time had been this sort of. I feel like the analytical world and the data world is really, for the most part, and again, not talking about big tech companies or companies that are operating where they need real time, but I think for the most part, we're still trying to catch up to just doing batch analytics in a useful way. And that's, I feel like now that the tooling's there, whether the practices are there or not, I think is a different story, which I'm working on. But I feel like
actually your work is really about helping lift the level of practice there.
Yeah, it's exactly it.
That's how I see your work anyway.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.